All right, lesson 3, tangent lines. Our aim for today is let's explore lines that intersect a circle at a single point. All right, so 3.1, swim to shore. Line L represents a straight part of the shoreline at a beach. Suppose you are in the ocean at point C and you want to get to the shore as fast as possible. Assume there is no current. Segment CJ and CD represent two possible paths. Right, so this is you in the ocean, here's the shoreline, and then you can either go in this direction to J or in that direction to D. Diego says, no matter where we put point D, the Pythagorean theorem tells us that segment CJ is shorter than segment CD. So segment CJ represents the shortest path to the shore. Do you agree with Diego? Explain your reasoning. All right, so again, we haven't really explored this topic yet, so no wrong answers. Just go ahead and make an assumption. Do you think that no matter where point D is, CJ is going to be the shorter distance? Okay, so Diego is correct that when we have a line that's point, the line perpendicular from the point to the line, right? From the point, creating perpendicular lines right here. That's always going to be our shortest distance. So it looks like it's true, but we want to prove it's true. And one way we often prove things are true in math is by contradiction. So I'm going to assume that CJ, or I should really say the measure of CJ, is greater than CD. All right, because we want to prove that CJ is shorter than CD, so I'm going to assume the opposite is true. And then based on this initial assumption, if something down the line doesn't add up, I know that my original assumption there's no way it can be true. I'm trying to find a contradiction here. So we know that CJ is perpendicular to line L. That's something that we know to be true. So if that is true, then we know that triangle CJD is a right triangle. With the measure of angle CJD equal to 90 degrees. All right, so given that angle CJD is right, the side CD must be what? Well, I really am asking you what must CD be? What kind of side does this have to be? Well, if it's opposite from this right angle, it has to be the hypotenuse. Okay, so why now, knowing that CD is the hypotenuse and CJ is a leg, why is this going to prove or disprove my initial assumption that CJ is greater than CD? Well, in a right triangle, the hypotenuse is the longest side. So CJ must be less than CD. this contradicts our assumption. So we can conclude that CJ is less than CD. All right, really quickly saying what I was really trying to show in this proof. If this is a right angle, that means that any line you draw, no matter where you draw it, right, that line is always going to be a hypotenuse, right? No matter where I draw this line. If this is a right angle, that extra line segment I'm drawing is always going to be opposite the right angle, so it's always going to be hypotenuse. So it's always going to make some right triangle, and it's never going to create a line segment shorter than this line here. So CJ, as long as it's perpendicular to the line, is always going to be the quickest possible path, or shortest possible path.